In this screencast, we're going to learn how to do some of the calculations associated with density in a Google spreadsheet. So if you'll recall, the types of problems we have are here. So we have the density D is equal to the mass M divided by the volume V, or D is equal to M over V. Sometimes I've called D the Greek letter rho, but we'll go with D for now. So as an example, we measured the properties of a steel ball, and we found that the mass was roughly 9 grams or 0.02 pounds. We found that the diameter was about half an inch. In this case, it measured out at 0.501 inches. So what is the density of that steel ball? Well, it's the mass of the ball divided by the volume. Now, the ball or sphere has a certain volume which we need to calculate, and there's a formula for it, as you can see it right here. The volume of a sphere is 4/3 times pi, 3.1415 or so, times the radius of that sphere or ball cubed. And the radius, of course, is just the distance from the center of the sphere to the surface. So since we measure, this is an engineering class, and we actually measure things, it turns out that the radius is not so convenient to be in this formula because we measure the diameter. So let's modify this formula to be in terms of, instead of the radius of our sphere or ball, it's the diameter. So how do we do that? Well, the diameter is equal to twice the radius, the diameter of course being the distance all the way across from one end to the other through the center, and it's just twice the radius. So if we solve for the radius here, we're going to get d over 2, diameter over 2 is equal to the radius. We put it into this original formula up here, and we get this formula here. This can be reduced through some algebra. I don't know if we really need to do it. I don't think we do. We can just start to plug in the numbers. So the volume of that steel ball is equal to 4/3 pi times d over 2, which is the radius, cubed. And if I just put in the numbers, I get a value out. We all have some calculators, and we can easily get a value of 0.066 cubic inches or so. So then when we calculate the density, which is mass over volume, we're going to get that weight or the mass that we measured of 0.02 pounds divided by what we just calculated, the volume of that sphere, 0.066 cubic inches. Do the division, and we get 0.30 pounds per cubic inch for the density of that steel ball. Okay, so that's hopefully straightforward, but there is an easier way to do it, and I want to show you how to do that. What we're going to do is we're going to use Google spreadsheets, Google Drive in general. We're going to go to create a spreadsheet, and we're going to get what looks like Excel if you're familiar with Microsoft. And what I'm going to recommend is that we use a triad of numbers. Triad means 3. So we're going to put in a label that's part of our triad of entries into one cell. So I'm going to put mass of steel ball here, and then I'm going to put its actual value. And if you'll recall, that value is determined by none other than our actual measurement, and we got 0.02 pounds. So we're going to put 0.02 pounds right into this cell here, 0.02, and we're going to put the unit here. Now, then we've got our data right there. The additional information that we need for the density is going to be the volume of the steel ball. And we went through a lot of trouble, a lot of algebra, which we'd like to avoid to get that volume. So instead of going directly to the volume, I'm going to put a little, I'm going to move this one. So I'm going to do a Control C, actually a Control X for cut, Control V for paste, and instead I'm going to put the diameter of the steel ball. Okay, and that was 0.501 inches. Okay, now with spreadsheets, of course, you can make them a little bigger to make things look a little nicer. And really these two lines here represent our measured data. Again, I'm going to move the volume down a little bit to make it a little more logical. I'm going to do a Control X to cut, come down one more, Control V, and I'm going to move down here. So everything down here is going to be calculations based on these things that we actually measured. So the volume of the steel ball was that big equation that was kind of unpleasant, 4/3 pi, diameter over 2 cubed. So I don't want to calculate that every time I want to have a new sphere that I want to measure. So I'm going to put an equation, a spreadsheet equation, into cell C6. It's going to have units, as we'll see, of inches cubed. So for the cubed, we're going to use a little caret to indicate we're raising the inches to the 3rd power. And here is where the new part comes in for some of you. We're going to actually write an equation in cell C4. So the first thing we do is write equals. And then I like to use a lot of parentheses just to make sure that I do the PEMDAS stuff correctly. So we had that 4/3 times pi. Now I'm going to put 3.1415. I think that's good enough for pi. So that's 4/3 pi. And you can see it's up here in the function window. And now I need to multiply this whole thing by the diameter over 2. But the diameter, I'm going to just click the location of the diameter in the spreadsheet. It's C4. So if I click there, I see C4 up there, and you can see it's right up there. And then I'm going to divide that by 2. And then finally I'm going to raise it to the 3rd power. Use the caret, which is the little triangle. And if I hit enter, it should think for a minute and then give me an answer. And this is in fact the right answer. So I didn't have to do that calculation once I had this formula right here. So I can go up to some of the other features here, and I want to have this out to 3 decimal places. So what I'm going to do is go to custom decimal, put in 3 and say OK, and it changes to 0.066 inches cubed, and that's actually the correct answer, I believe. If we come back over here, yeah, 0.066. Okay. Now, I don't really want the volume per se. You want to use that as just one component of a calculation. I ultimately want the density. So I'm going to say the density of the steel ball. It's going to go right here. Now the density is the mass divided by the volume. So I have everything I need. So I can say equals the mass divided by the volume. Enter. Thanks for a minute, gives me the right answer. And I'm going to immediately put in the right units. And I know what they are because I have them in column D. So it's pounds per cubic inch. And again, I'm going to come here and make this into 3 decimal places. And I've got my answer, 0.304. And I cut it off here in my manual calculation at 0.30, but there was a 4 there, if I remember correctly. So that's the way you make a spreadsheet which can do your calculations for density. Now, where the power of this really comes in is if you want to kind of have another calculation. So what I'm going to do, just to kind of keep things neat, I'm going to grab some rows here, come up here, I'm going to get it a different color, nothing too flamboyant, But I'm going to take this whole thing and I'm going to do a Control C for copy. I'm going to click here in cell B12 and do a Control V, and I've duplicated the whole thing. So let's make sure this equation is right. So it should take 4/3 pi times the value in this cell, the diameter of my sphere, and divide it by 2. So it's now C13 instead of up here it was C4. So that worked. Now what I can do is keep these blank, and what I'm going to put a box around is really the most important part. So say I have a mass of 0.05 pounds, and the diameter is a little bigger at 0.75 inches, 75 inches, yeah. And as soon as I put those numbers in, my volume and my density are immediately calculated. Okay? So we could even highlight these with a different color maybe to show that these are formulas that do the work for us. All we have to do is put the numbers into, say, the green. So we could put a little note here, put measured values in green cells. Oops. Let me just take that out and make this back to where it was. Need to make this one a little bigger. Okay. And then calculated values are in yellow cells. And I've got basically a density calculator at this point. And if I want to do many different values, I can just put the values in here and read it off. Or if I want to save it and keep a database of the things I've measured, I can just keep copying and pasting this guy one more time down here. So I can take this guy, copy, paste, and since we're working in the cloud with Google, you can see it's working up here to paste this thing, but it'll appear eventually. So this is how you set up a spreadsheet to do calculations for you. And there it goes. I'm going to give it a name. I'm going to call it read John underscore density. This time I'm going to call it 2. So this is kind of our second attempt at making this. And there you have it. This would be how you would make a spreadsheet to do the calculations for you.